Measuring line segments. In the earlier chapters, we have already studied about the line segment. It is a fixed portion of a line. Hence, it is possible to measure it. The measure of the line segment is called its length. Using this idea, we can compare line segments. We have different methods for comparing line segments. Comparison by observation. We can compare line segments simply by looking at them. For example, here the line segment PQ is greater than AB. But sometimes we cannot be sure about our judgment. For example, in the animation, we cannot be sure which line segment is greater than the other simply by looking at them. So we cannot rely on this method for accurate measurement of line segments. Comparison by tracing. Another method of comparing line segments is by tracing. Using a tracing paper, trace AB and place it on CD. Now we can easily tell that CD is greater than AB. Accuracy of this method depends upon the accuracy of the trace. Also, it is hectic to trace a line segment every time we want to compare it. Comparison using ruler and a divider. First, let us know about a ruler and a divider. A ruler is divided into 15 parts, each of which has length 1 centimeter. Each centimeter is divided into 10 subparts, each of which is of length 1 millimeter. Now let us measure the length segment AB. Place the 0 mark on the ruler at one end of the line segment, say A. Read the mark at B. It is 5 centimeters, so the length of AB is 5 centimeters. Let us draw a line segment AB of length 8 centimeters. Now let us measure AC. It is 4 centimeters. Also, BC is of length 4 centimeters. So we say that C is the midpoint of AB. To measure a line segment by a divider, open it and place the end point of one of its arms at A and the end point of the second arm at B. Now, without disturbing the opening of the divider, take the divider and place it on the ruler. Ensure that one point of the divider is at the 0 mark of the ruler. Now read the mark against the other end point of the divider. Now let us compare line segments using ruler. Draw a line segment of length 8 centimeters. Mark it as AB. Draw another line segment of length 10 centimeters and mark it as CD. Clearly, CD is longer than AB. Angles. Right, straight and complete. An angle is the figure formed by two rays, called the sides of the angle, having a common endpoint called the vertex. You must have heard the terms such as take a right turn. What do you mean by taking a right turn? Or particularly, a right angle? Consider a boy standing on a crossroad facing towards the north direction. To face the east direction, he takes a left turn. The angle made by him here is a right angle. The shape of a right angle resembles to the English alphabet L. Now if the boy turns to the south direction, he takes another right angle. That is, to go from north to south. He has to take two right angles. This angle is called a straight angle. Now, if the boy again turns by two more right angles, he reaches back to where he was standing originally. That is, he has taken a complete turn. This one complete turn is called one revolution. The angle for one revolution is a complete angle. Look at these rays. These rays form a right angle with each other. Can you think of an example of a right angle? Notice the position of the hour and the minute hands of a clock at 3 o'clock. The angle formed between the hands is a right angle. Now we know that two right angles form a straight line. So the hands of a clock form a straight angle at 6 o'clock. Now if we take two straight angles, we get a complete angle. So when the minute hand makes an entire revolution in 60 minutes or 1 hour, it forms a complete angle. Similarly, if the hour hand makes an entire revolution in 12 hours, we say that it has moved by a complete angle. So, two right angles form a straight angle, two straight angles form a complete angle, and four right angles are equal to one complete angle. Now let us consider another example. Consider a wheel with 12 strokes. Here 1/4 of the revolution makes a right angle. 1/2 of the revolution, that is, two right angles, make a straight angle. 3/4 of the revolution is equal to three right angles. And one complete revolution is equal to four right angles, which is equal to one complete angle.
Children, listen here. Is the figure pointing the four directions: north, south, east and west. So imagine you are stand facing north. Okay, imagine you are stand facing north. So yeah, turn to east. Okay, stand facing east. Okay, so yeah, north to east. So north to east, east to south, south to west, then again west to north. So this is the clockwise direction of a one revolution. From where you start ends at the same point. From north, you are standing facing north, then again come back to the same position is a one complete revolution. Okay, one complete revolution and one complete angle 360 degree. Okay, so here, so north to east, east to south, south to west, west to north is the clockwise direction. Okay, then again it's north to west, west to south, south to east, east to north is the anti-clockwise direction. Okay, clockwise direction is also there, anti-clockwise direction is also there. So imagine you are stand facing north. So you have to turn to stand facing east, facing east. So how many right angle? North to east is one right angle. Okay, number of right angle one measure is 90 degree. So okay, 1/4 part of a revolution. So four right angles make four right angles make one revolution. So the fraction part is 1/4. Okay, 1/4. Or you can write a 90 degree by 360 degree. This is the 90 degree by 360 degree. It changes to 1/4. Okay. Then next you have to north to east there. Then again north to again changes to south. Okay, north to east. Then again changes to east to south. So north to south is the straight angle. Straight angle means is how many right angles you cover? 1, 2, two right angles. Okay, two right angles and 180 degree. Okay, 180 degree. Then is the here is 180 degree by 360 degree, or you can write is 1/2. Okay, 1/2. 2 times 180, 2 times 360 degree. Okay, this is the fraction part of a revolution. Okay, then again next is you first turn to east, then turn to south, then turn to west. So here 1, 2, 3 right angles. So how many right angles? Is 3 right angles. So 90 degree plus 90 degree, 180 degree. 180 degree plus 90 degree is 270 degree. So here 270 degree by 360 degree, or you got 3/4 of a revolution. 3/4 of a revolution. So yeah, standing facing north, then turn to east, then turn to south, then turn to west, then again come back to the same position. So here is one more right angle. 1, 2, 3, okay, 4 right angles. Okay, 4 right angles. It's 270 degree plus 90 degree is 360 degree. Okay, 360 degree by 360 degree you got 1. Okay, one full revolution. Hope all of you understood. This is the way you find the is part of revolution and the number of right angles. Children, next we are moving to exercise 5.2. First question. What fraction of a clockwise revolution does the hour hand of a clock turn through when it goes from 3 to 9? First question, 3 to 9. So consider, imagine a clock is clockwise direction. Clockwise revolution means is here 12, 1, 2, 3, 4, then again comes at 12. That's the is clockwise revolution. Okay, does the hour hand of a clock turn through when it goes from 3? So the hour hand faces to 3. Okay, here consider 3. Okay, 3. Our hand faces the 3. Okay, then is next is 4. Okay, then 5. Then 6 is there, then 7, 8 and 9. Okay, so this is the, so our hand is in is this direction. Okay, this is the straight line. Okay, all of you understood? So 3, 4, 5, 6, 8, 9. Okay, so is the is 180 degree. So here is how many, what part of a revolution is half, 1 by 2, half of a revolution. Okay, then again B question, 4 to 7. So here is our hand is facing 4. Okay, 4, our hand is facing 4. Then after is 5, 6, 7. 7 is there. So that's in this direction. Okay, in this direction is the our hand changes. So here is 1 right angle 90 degree. So what part of a revolution is 1 by 4 of a revolution. Okay, hope all of you understood. So then next is 7 to 10. Okay, so 7 is there, our hand is facing 7, then 8 is there, then 9 is there, then 10 is there. Okay, so yeah, our hand is facing in this direction. Okay, 7, 8, 9, 10. So here also is 1 right angle is 1 by 4 of a revolution. Hope all of you understood. Okay, questions D, E and F do as homework. Okay, remaining questions D, E and F do as homework. Second question. Okay, second question, where will the hand of a clock stop if it starts at 12 and makes 1 by 2 of a revolution clockwise? Okay, so imagine the clock. Okay, imagine clock in your mind. Then clockwise direction means is starting from 12. 1, 2, 3, 4, 5, 6, ends at 12. Okay, starts at 12 and makes 1 by 2 of a revolution. So 1 by 2 of a revolution means is 180 degree. 180 degree means is a straight line. Okay, so starts at 12, then straight line comes, starts at 12 and ends at 6. Okay, hope all of you understood. Okay, B question, starts at 2 and makes 1 by 2 of a revolution clockwise. Okay, starts at 2. So our hand is in is 2. 2 and is comes as 1 by 2 of a revolution. So 1 by 2 of a revolution means, okay, it's again is a 180 degree. 180 degree means is a straight angle. So our hand ends at 8. Okay. Then next C question, starts at 5 and makes 1 by 4 of a revolution clockwise. So starts at 5 and makes 1 by 4 of a revolution clockwise. So our hand is in 5. Okay, fine. So here is the, okay, this is the direction. So 5, 6, 7, 8. So by 4 of a revolution, 90 degree. So inside 8. Okay. Then D question, do as homework. Okay, D question, do as homework. Children, next is the fourth question. Third question, you do as homework. Fourth question, what part of a revolution have you turned through? If you stand facing east and turn clockwise to face north. So here is north to east, then east to south, south to west, west to north is the clockwise direction. Okay, from starting from north, yes, north to east, east to south, south to west, west to north is the clockwise direction. When starting from east, it's the clockwise direction. Yes, east to south, then south to west, then west to north. Okay, is the clockwise direction. So, east and turn clockwise to face north. So, east and turn is clockwise to face north. So, east to south, one right angle. South to west, another right angle. Is west to north, another right angle. So, 3 right angles. So, what part of a revolution is 3 by 4 of a revolution. Okay. Then again, south and turn clockwise to face east. So, south and turn clockwise to face east. So yeah, again is south to west, one right angle, west to north, another right angle, north to east, another right angle, 3 right angles. So, what part of a revolution is again 3 by 4 of a revolution. Okay. Then C question, west and turn clockwise to face east. So, west and turn clockwise to face east. Okay. So, west to north is 1 right angle, north to east is 2 right angles. So, what part of a revolution is half of a revolution. Okay. Hope all of you understood. Next, fifth question is do as homework, and then sixth. Okay. How many right angles do you make if you start facing south and turn clockwise to west? Okay, south and turn clockwise to west. So, here also north, south, east, west. Okay. Right angles do you make? Start facing south. So, starting from south. Okay. South and turn clockwise to west. As a south to west, how many right angle? Is a south to west is only 1 right angle. Then again B question. North and turn anti-clockwise to east. So here anti-clockwise. So here north to east, east to south, south to west, then west to north is the clockwise direction. Then is the opposite is the anti-clockwise. North to west is west to south, south to east, then again east to north. That is the anti-clockwise direction. So, north and turn anti-clockwise to east. North and turn is anti-clockwise to east. Okay. So, north to west, 1 right angle. West to south is another right angle. South to east, another right angle. So, 3 right angles. Okay. 3 by 3 right angles. How many right angles? Is 3 right angles. Then next C question, west and turn to west. So, west and turn to west is the complete revolution. Okay, whether it is anti-clockwise or clockwise direction, it's one complete revolution. So, how many right angles? Is 4 right angles. Okay, then south and turn to north. South and turn to north. So, whether it is anti-clockwise or clockwise direction, is the how many right angles? Is a half of a revolution. How many right angles? It's 2 right angles. Hope all of you understood.
Angles: acute, obtuse and reflex. Let us first make a right angle tester. Take a piece of paper. Fold it as shown in the animation. The right angle tester is now ready. Observe these figures. All of these form an angle. Let us compare these angles using the right angle tester. We see that each of the angles formed is smaller than a right angle. Such angles are called acute angles. Also, there are angles which are greater than a right angle, but smaller than a straight angle. Such angles are called obtuse angles. For example, a rooftop, a Chinese fan, etc. An angle which is greater than a straight angle and less than a complete angle is known as a reflex angle. Measuring angles. We learnt to compare angles using a right angle tester. To be more precise in comparison, we need to measure the angles. The instrument used to measure an angle is called a protractor. Angles are measured in degrees. The number of degrees tells how wide open the angle is. Degrees are marked by a degree symbol. There are 360 degrees in one complete angle. A right angle measures 90 degrees, a straight angle measures 180 degrees, and a complete angle 360 degrees. Now let us measure this angle AOB. Place the protractor horizontally over the line OB in such a way that O and M coincides with each other. Clearly, we can see that the side OA falls on the mark of 50 degrees. So, the angle AOB measures 50 degrees.
Acute angle, obtuse angle, reflex angle. Let us look at them one by one. Acute angle. Look at this picture of an open door. Can you identify the angle that it makes with the ground? Yes, 90 degree. Now shut the door slowly. Can you identify the angle that it now makes with the ground? You're right, less than 90 degree. Obtuse angle. Let us go back to the picture of open door. What do you think will happen if you push the door further to the right? The measure of the angle will exceed 90 degrees. Angles that measure more than 90 degree are called obtuse angle. Reflex angle. Look at this cake. 1/4 of it has been sliced out. A full cake makes a complete angle of 360 degrees. 1/4 of the cake sliced out forms 90 degree. The cake that remains forms 270 degree. Angles greater than 180 degree are called reflex angles. Measurement of angles. Let us now learn to measure angles with a protractor. Protractor is a semicircular geometric instrument with markings from 0 to 180. These markings represent degrees. The outer markings are used to measure an angle whose vertex is formed on the left. The inner markings are used to measure an angle whose vertex is formed on the right. Measure angle AOB with the help of the protractor. Place the protractor on ray OB. Ensure that the horizontal line at the bottom of the protractor coincides with OB and its midpoint rests on vertex O. Check the inner marking that coincides with ray OA. It is 60. Therefore, the measure of angle AOB is 60 degree. Measure angle MON with the help of the protractor. Place the protractor on ray OM. Ensure that the horizontal line at the bottom of the protractor coincides with ON and its midpoint rests on the vertex O. Check the outer marking that coincides with ray OM. It is 120. Therefore, the measure of angle MON is 120 degree.